In this experiment, you will examine representative reactions from the three fundamental classes of chemical reactions: precipitation, acid-base, and oxidation-reduction. When observing that a reaction occurs, the products for the reaction must be identified, and the balanced chemical equation recorded, complete with necessary coefficients and phases. This 2-week lab is completed individually. Precipitation, acid-base, and redox, or oxidation-reduction, represent the fundamental categories of chemical reactions. Although most reactions fit into one category, there are instances where a reaction can be classified in more than one. Categorizing a reaction is completed by observing the products formed when mixing the reactants. Precipitation reactions form at least one product that is insoluble, usually from aqueous solutions. An acid-base reaction involves the transfer of an hydrogen ion from one reactant to another. A redox reaction requires that at least one electron is transferred between reactants. The full balanced equation for a precipitation reaction shows all reactants and products, complete with phase. A solubility table allows the formula of the precipitating product to be identified. In a net ionic equation, the spectator ions, which are present in the aqueous phase as reactants and products, are not included. When an acid and base react in aqueous solution, a salt and water are formed. This is a useful rule to help identify the salt product in this type of reaction. Upon removing the spectator ions when writing the net ionic equation, the acid-base proton transfer shows the formation of water. One example of an oxidation-reduction reaction involves a metal and acid reacting to form a salt and hydrogen gas. At least one product in this reaction could be predicted using the guidelines for predicting reaction products. The net ionic reaction clearly shows the oxidation of aluminum metal to form a +3 aluminum cation, and the reduction of +1 hydrogen ions to form diatomic hydrogen gas. In this reaction, the aluminum metal is oxidized, or gives up electrons, and the hydrogen ions are reduced, or gain electrons. Observations are critical to correctly classifying a reaction. An insoluble solid must be formed in precipitation reactions. Acid-base reactions show either the formation of a gas or a change in the color of an indicator, assuming it is present. Oxidation-reduction reactions can produce the same visible changes as both precipitation and acid-base reactions. The use of p-hydrion paper can identify an acidic, neutral, or basic solution. A single strip of p-hydrion paper is torn into 3 or 4 pieces, the pieces put on a watch glass, and then a drop of test solution transferred from the test tube or beaker onto one piece of p-hydrion paper. The appearance of a red color on the paper indicates that the test solution is acidic, light brown indicates a neutral solution, and dark blue a basic one. When a metal is heated in air, it will combine with oxygen and form the metal oxide. This brightly burning metal is magnesium, and the solid product that is formed is magnesium oxide. Compare the shiny magnesium metal on the right with the dull white magnesium oxide on the left. This change in physical appearance suggests that a chemical reaction, in this case a redox reaction, has occurred. 2 resources can help identify the products formed in a chemical reaction. The resource Predicting Reaction Products provides useful rules for product formation when reacting certain kinds of substances. The salt solubility table helps identify a precipitate if a solid is formed during a chemical reaction. Both of these resources are in the Classes of Chemical Reactions experiment in lab archives. Once all the products are identified, then the reaction can be classified as precipitation, acid-base, or redox. Phases need to be properly identified in an equation. Precipitates are represented in the solid phase and a soluble salt in the aqueous phase. Standard safety precautions include wearing goggles, an approved lab coat, and closed-toe shoes. Any skin exposure to either acid or base must be immediately rinsed with large amounts of cold water. Your TA will neutralize any acid or base spills on the countertop with sodium bicarbonate. Silver nitrate is not considered dangerous but will stain the skin. Gloves should be worn when handling this reagent. Please do not remove any reagents from either the reagent bench or reagent hood. This allows everyone in lab to easily find the reagents. It also provides a safe lab environment for everyone. Use deionized water from one of the marked containers in lab to dilute any test solution. Don't return any unused solution to a bulk reagent container. This is how reagents become contaminated. After dispensing a reagent, replace the cap on the container. Put any unreacted metal and the provided plastic containers in the sinks. When you are finished, clean up your bench area as well as your hood.